Alright guys, we continue doing differentiation that's dedicated to basics, differentiation rules. However, questions might be a bit more tricky in the end. We start from simple ones. Of course, if you need to memorize all those rules, I advise you to watch videos dedicated to rules of differentiation. Here you can see Leibniz notation. So in terms of d something, dx, so that means we differentiate. Okay, and if you need to know how actually why those rules actually behaves like that, please watch the video dedicated to proofs. And let's get started. So grab your pen, grab your notes, let's start doing that. Find dy dx for the following functions. Dy dx simply means derivative y prime, okay, with respect to x. So here you can see sort of radicals. That's fifth power of the root x to the power 4. So that's why let's first rearrange in order to get proper way, because you can differentiate in this case using power rules. You can differentiate polynomials or polynomial structure. Okay, so that's why let's make similar to that. So it's going to be 3 to the power x, so x to the power 4 over 5, okay? That's going to be the power. And now you have simple standard form. So you have c times x to the power n. And you differentiate that. So right now you're going to find prime or derivative for g. According to the rule, you are going to use constant multiple rule. That means c, and x to the power of n prime is going to be simply c times n, and you diminish the power by 1. So in your case, the power is 4 over 5, so that's why first you don't touch 3. And if you start differentiating x to 4 over 5 prime, you'll get 4 over 5 goes before, so that's why you'll get 3 times 4 over 5, which is 12 over 5, okay? And the power lose 1, so that's why 4 over 5 minus 1, that's the rule, okay? So finally you'll get 12 over 5, and you'll get negative 1 over 5. So if you want to go, so x to the negative 1 over 5. If you want to go back to your original structure, you need to write that it's going to be 12 over 5, and x, because the negative power, that simply use index rule, so x to the negative, let's say first negative k, it's simply 1 over x to the power of k. In your case, k is 1 over 5, so that's why it's simply, so x to 1 over x to the power 1 over 5 will look like as 1 over fifth root of the x. So that's why finally you'll get 1 over fifth root of x, okay? Just make sure you remember how to use index notation. And if you rewrite, so you can write finally that g prime simply is 12 over 5 fifth root out of x. So that's the final result. Okay, so let's go to the next one. You'll get 1 over 2. So that means you're going to differentiate as, so f prime is going to be 1 over 2. You immediately take out the constant multiple, and x, 1 over square root of x cubed, you just can rearrange as x to the power negative 3 over 2, okay, because you have square root. So that's why it works like 3 over 2, but now you lift it up, so you need to lift it up. That's why you are going to use negative power. So, and you take the prime. So finally you'll get, if you differentiate that, you'll get negative 3 over 2. On top of that, you multiply by 1 over 2. And your x will be in the power negative 3 over 2 and negative 1, okay? So you'll get negative 5 over 2. okay? So that's why f prime is gonna be equal to negative 3 over 4. Because negative power, you put your x to the power 5 over 2 to the bottom part. So x 5 over 2. And finally, what you're going to do, you just need to write in the same way as you had before. So that's why you're taking the square root of x to the power 5. But if you like, you can simplify, because you can decompose x to the power 5 as x to the power 4 times x. So we believe that x is going to be more equal than, strictly more than 0. So that's why we can rewrite as the following. So 4x squared, yes, because we're taking the square root of x to the power 4, and 1x left inside, okay? So that's the final way of how you have a prime from f. Okay, so we've done A, we've done B, and now let's go to C. So fx, this is the fractional expression, so that's why first let's simplify. What I'm going to do, I'm going to divide by parts, so make partial division. 3x cubed over 5x fifths, x to the power 5, is going to be 3 over 5. And using the index rule, x to 3 over x to the 5, I just simply subtract powers. 3 minus 5 is going to be negative 2. So it's going to be x to the negative 2. And finally, we have negative 4 over 5 and x to the negative 4. Okay, now we have the same structure in order to apply power rule right now. So let's apply that. And let's find prime. So f prime is going to be equal to, in case of C, 3 or 5 is constant multiple. So that's why we take it away. So then we differentiate x to the negative 2. So we just simply times negative 2 right now. And the power we diminish by 1. So that's why the power is negative 3, okay? And here is the next one. Negative 4 goes before, so that's why you swap the sign into the positive one. It's going to be 4 times 4 over 5. So 4 over 5 times 4 right now. And the power again diminished by 1, so that's 1 negative 5. Okay, so if we rewrite finally, f prime is going to be equal to negative 3 times 2, negative 6 over 5, okay? And x to the power negative 3 will give us 1 over x. So, if you like, you can write like this, 1 over x to the power 3, okay? And on top of that, you need to add 16 over 5 times, and again, x goes down into denominator, and power becomes positive, okay? So that's the final answer for that. If you like, you can go to the common denominator if you like that. So that's why we can do the following. So if you want to rewrite this as the common denominator for the f prime, so you can write the following. So the common denominator in this case is going to be 5, yeah. So it's going to be just 5 x to the power 5, okay. X squared goes there, so that's why it's going to be 16x squared. And, sorry, my bad. 16 doesn't have anything, right? Because x cubed is here, so x squared goes there, so that's why minus 6x squared. Okay, so this is the way how you can rearrange. If you want, you can just check and it should work. Okay, so that's done. That's for final C. Okay, let's go to the next one. So we are given that 3x to the power 2 over 3, if the function is, what is the derivative of f with respect to x? So in other words, we just need to differentiate and find derivative of that. Okay, so just simply find derivative and we'll get 3 x to the power 2 over 3, which is taking derivative, okay? 3 times 2 over 3, and x goes with the power 2 over 3 minus 1. Okay, so that's why we'll get 3 and 3 will be cancelled, so we're left with 2x, and power 2 over 3 minus 1 is going to be 1 over 3 with negative sign, negative 1 over 3. So if you like, you can rewrite in their third form, so now third form, okay, and it's going to be 2 over cubic root of x. So just make sure you remember how to work with indices. That's the key aspect here, okay, or a key skill that you can pick up from GCC. If you're not sure, just go back to GCC where you can find that and try to watch how to work with indices. Okay, so differentiate R with respect to C. So in this case, C is not constant, but it's a variable. So C is a variable. So that's why your result shouldn't be 0, because your function actually R is depending on C, okay? So that's why you need to find actually the prime with respect to C from C, okay? So, but first, I want to just rewrite this expression in proper manner using powers, okay? And using primes now. So I use the property or rule of differentiation for the sum and difference. In this case, we have sum. And I just differentiate each one, okay? C negative 1 prime. So C is actually C derivative, or C prime is going to be 1, because the power is 1, right? So that's why it's 1. And C negative 1 prime is going to be negative C negative 2, okay? If you just simplify that, or just go back to your original way or original form, you'll have this, okay? So next one. Find dy dx if you have this. Okay, so you need to find, in other words, you need to find y prime. But unfortunately, you don't have y expressed. So first, logically, you need to express y. So before doing that, express y as the function of x. Of course, you might use implicit differentiation, but this is too early to apply that, and it's going to be more complicated. So that's why I would recommend to just simply express y from x. Okay, so let's do that. Y is going to be equal to, just transfer negative 4x that side, and on top of that you'll have square root of x, then minus 6x to the power 4, and then because you have this factor before y, let's assume you expressed the first 2x squared y, and now you just divide by 2x squared, okay? But right now you need to simplify and make all in the powers, okay? So that's why it's going to be 4x. Let's do partial division, so each term on the top, so in the numerator of this fraction, divide by 2x squared. So that's why it's going to be 4x over 2x squared is going to be 2x to the negative 1, okay? Square root of x, I represent as x to the power 1 over 2. So that's why the resultant power is going to be, so first 1 over 2, the constant multiple, and x 1 over 2 minus 2. So x 1 over 2 minus 2. And finally, minus 6 over 2 is 3x squared, okay? I just rewrite this middle term because this, in this case, x 1 over 2 minus 2 is going to be x to the power negative 3 over 2. And right now, we are going to differentiate that. So y prime is going to be 2x minus 1 plus 1 over 2 that, and minus 3x squared, we differentiate that, okay? So obviously it's not so hard. So y prime, in this case, is going to be equal. So using the sum rule of differentiation, we'll get, so 2 negative 2x negative 2, okay? Next, 1 over 2 and negative 3 over 2 will get negative 3 over 4. In this case, I just a little bit accelerated. And the power is going to be x negative 3 over 2 minus 1. So that's why minus 5 over 2. Yeah, every time just decrease the power by 1. And finally, we'll get negative 6x to the power 1. So that's your final expression for derivative in case A. Okay, so this is dy dx. dy dx. Okay, so let's also do that B. So in B question, you have 3y. So first, again, express y. So we do the same. So express y from x. In other words, make y as the subject. So right now, y is going to be equal to 5x to the power of 5. Then I just transfer 4x squared with negative sign, so swap the sign to the positive. And finally, minus 2 and everything over 3. Okay, so everything over 3 means that each coefficient is going to be over 3. So that's why I just simply take away constant multiples immediately and taking derivative of x5 is going to be 5x to the power of 4. Next, 4 over 3, that's constant multiple. And x squared prime is going to be 2x. And finally, minus 2 over 3 is the constant, so that's why it's 0. Okay, so finally, if you simplify that, you'll get a final expression. It's going to be 25 over 3 x4 and plus 8 over 3 x. So that's the final solution. All right, it's done with that. Okay, so challenge in math. Find equivalent expression for the n's derivative. Be careful, n's derivative. So remember, if you differentiate once, it's going to be the first derivative or the prime. For example, let's assume, before we do that, let's assume that y is going to be x to the power, let's say 4, okay? If we first differentiate, we'll get 4x cubed, right? If we next differentiate, so we take in derivative, the second derivative from the original function, that's original one, but we can say that we can take derivative from the first derivative, all right? So that's why right now we are going to differentiate 4x cubed prime and make it prime. So that's why final result, constant multiple, right, rule, 4 times 3x squared. And if we take the third derivative, that's going to be 4 times 3 times 2 and times x, right, to the power 1. And if we differentiate the first time, so in this case, I just use not primes, but I put number 4, okay? So that's why if we differentiate the last time, we'll get 4 times 3 times 2, and times x is going to be 1, okay? So what we notice that if we differentiate 4 times, so 4 times differentiation, okay, it means that if we had x to the power 4, so number of times should correspond to the power of your x, we'll get 4 times 3 times 2 times 1. If we take the fifth derivative, so if we differentiate 5 times, it's going to be absolute 0, right? So that's why we can differentiate with no losing value 4 times. Otherwise, final we'll get 5 times, 6 times, and more. We'll get constant, which is simply 0. The derivative of that is going to be 0. Okay, because the previous function is the constant. But look, let's have a look at the pattern. We've got 4 coming from the power, then we got 3, so that also get 2 from the power diminished by 1, then we'll get 2, and then we'll get finally 1. So looks like you will have 4 factorial in the end, if you know what I mean. So factorial is just the product of all numbers, all natural numbers from your given one up to the last one, okay? So consecutive natural numbers starting from your number up to 1. So obviously you would expect here to have n factorial in the end. So this is an alternative or equivalent expression for n's derivative. But if you want to prove general, so we did it on using private case, so we can do it easily. So the first derivative d dx of x to the power of n is going to be n x n minus 1. Then using the second derivative, so it's going to be prime, and if you differentiate that, you'll get n times n minus 1 times x to the power n minus 2. So notice that we, let's assume that we mark as y, okay? That's your function, y from x equals to x to the power of n. Actually, we took the first derivative and the second derivative. So just keep going that, continue this process on the step n using the n's derivative, and we denote like n's derivative. We'll get obviously n times n minus 1 times, and finally the final step, yes, is going to be n minus n minus 1, which is simply 1. So that's our stopping point, and that means that n's derivative finally will give us n factorial. So that's why n factorial is the alternative expression for that. Okay, that was a little proof, but that definitely challenged math or complicated problems. Okay, make sure you understand that, and that's very nice skills to generalize. You'll need that during your proof when you use inductions, for example, methods, or using contradiction. No matter, but mostly it's mostly applicable for induction. Okay, so make sure you understand that. If not, just go back to explanations for powers rules, for constant multiples rules, and for other rules of differentiations. And don't forget to visit A level. Oops, sorry, man. So man is my smartphone. Okay, so A level, the lens class, and see you next time.